Okay, take it away.
Okay,
So,
all good. Okay, today we're going to walk through like a little walk through about Golang. It's a quick intro, trying to show you the main features of Golang and
hope you like it. So let's start. A little bit of background.
Golang was released not long ago, just in 2009 at Google. Briefly, I can tell you that they were looking for options on how to improve their processes, and they had like several projects that they had problems with concurrency and parallelism. So basically, these three guys, Robert, Ross, and Ken
Thompson decided to create something that is similar to the cool tools like Python and Java, to start working on a nice solution for the problems they got. This guy, Rob Pike, is the creator of UTF-8. He has a good videos on YouTube. I encourage you to take a look at that. It's a lot of things. Interesting. One of the key points in here on this that currently have Golang in several tools that I think that almost everyone uses every day, like Terraform, Kubernetes, Docker, and there is a reason for that. Basically, Golang is based on concepts from C++, Java, and Python. One good point in here is that Golang is compiled. You don't need to have any virtual machine or anything in the middle to start running. You just compile and ship your binary to any platform you want. One of the things that makes it interesting is this is textually typed, but at the same time it can infer the types on your code. It's supported in several platforms. You can run it on your Mac and Windows, anything. Indeed, you can run Golang in RISC processors, which is really good because you can run Golang in old computers. This kind of factors like PC and the others. I would say that Golang is CI/CD friendly because you don't have to have any other requirement to start shipping your binaries. You only have just to compile and check your code, but it's really easy to start working on doing some CI/CD. So I would say that it's really DevOps friendly. Paradigms. Golang is imperative and it's object oriented. One of the things that it's weird is because you don't have classes, but you have interfaces. That is something that we're going to look next. And one of the cool things about Golang is concurrency. And the way that Golang handles the concurrency, you don't have to take care of like locking and all of that. It's a really complicated thing that would serve like another talk about this topic. What is like Golang? It has no classes, no structure, no annotations. If we do a comparison between Golang and Python, for example, by creating the Mandelbrot set, it took just 7 seconds. As opposite of Python 3, that takes like more than 200 seconds to generate the Mandelbrot set. You will see comparison, for example, Go versus Java. Again, the same thing. They're close, but the way Golang works is better than others because it's compiled, so you don't have to pass in mail or interpreter or something like that. Where do you get it? From here, Golang.org. And I would say that Golang, one of the cool things about it is it has everything that you need to start working on. You need, for example, HTTP packages. or do you need to parse in JSON file? You don't have to get anything outside because it has a lot of features inside, so you can start working on. So let's go to the basics, the classic hello world example. So Golang is pretty much as C or C++, but it has a different approach. So I'm going to start really fast with this. I have like, okay, here. So let me show you what a hello world looks like, and we can start playing around with it. So for example, here we have just the package that we're working on, the main function, the classic one. You're not encouraged to have a semicolon to compile your program. And at the end, this will run or be compiled like this. You can do something like go run hello world, and that's all. And it creates a binary for you, so you can execute it by doing this. No, this one. It's because you have to do something like this. And here is it. It's a binary. So that's the thing. Even if you have a script that use several modules on, or you have a hierarchy for organizing your code, you don't need to take care about that, because when you build, it will ship everything in the binary, and you don't have to worry about anything else. You just ship the binary as a package. So that's one of the cool features that we have. So let's move into the basics, syntax basics. Okay. So variables, how you define a variable in Golang. It all depends. If you want to strictly type your variable, the name of your variable, the kind of your variable, you have just to put the type in front of the name of your variable. So there's a couple of ways that you can use your variables. It's one is to append the keyword bar in front of the name.
Sorry, just remember to present back.
Sorry. Yeah. Yeah, and all you have to do is just to put the variable name and the type. And if you don't want it and you want Golang to identify the kind of variable that you're working on, just not use bar, but semicolon and equals, and it'll automatically detect the kind of variable that you want. That's the way you work with variables. Control structures. If then else, all of that. It's the main in between Golang and other programming languages like C or C++ is, for example, in the if, you don't have to add parentheses. So you just put if and condition, anything that you want to put in there, curly braces to put your code in, and that's pretty much how you write an if statement. Oh, okay. Let's move into arrays and maps. It's somehow at first sight is difficult to think about that, because you have to define size of the array. And basically, array is just the basic array that we know, and maps is just like in Python dictionaries, just a key value. And here, if you see, you're using the other way to define variables. So y equals, and in here we're just creating an array of 5 elements, and you are creating the variable and putting in there the values inside the variable. That's all. And if you see in the for statement, you will see that we're walking through the array, and this syntax, it's similar to the if statement. For the for statement, you don't have to put parentheses. And if you see the underscore comma b, the underscore will be an ignored variable inside your for loop. So if you want to read, it will read automatically for you the key and the value of the array. In this case, it will read the key will be the index of the array, 0, 1, 2, 3, and the value itself. And range, it will walk you through the array. That's the way array and maps works. Functions, really easy. But the syntax is a little bit different as we know it in other languages. To define a function, you only have to put the func keyword, the name of your function, and signature of your function. I think that's something that you're familiar with. But the only difference that you have in this case is in the signature of your function. If you have the same type of parameters like x and y, they're both integers. You only have just to put the name of your parameters and the variable type. That's all. And at the end, you will put what will be the kind of data that you will be returning. In this case, you will return the sum of x plus y. That's it. One of the things that makes the Golang different in comparison with other languages is structures interface. Here, if you see the way that we define a structure, it's because we want to create a new kind of data type. In this case, you have, for example, classic ones, integers, strings, but let's say that you want to create your own data type. So in this case, I'm creating, for example, if you see in the code, type employee will be a new kind of variable, employee. It has name, age, and rate. And there is a way that you can make that data type to have functions inside of it. Like, for example, employee.amount to pay. This way, using an interface, the interface will say something like this. Okay, if there's any structure having this method with the name amount of pay, it will automatically, I will identify that as a contractor, no matter if he has any other kind of methods inside of it. But if you implement amount to pay, automatically Golang will say this one is a contractor. We'll see more examples in there. And I will stop in here just to walk you through the code. And at the end, we'll return to Go routines, which is the reason why I want to talk about Golang, that is Go routines. But we'll go into that topic later. Okay, so we were in functions, right? So if you see here, for example, it's really easy. Function, the name of the function, the kind of parameters you have here, return type, and that's all. So you can simplify that and just put at the end the kind of data that the parameters are. That's all. Pretty easy. And here, for example, if you want to check if a number is even or odd, that's pretty much, it's really straightforward. And one thing, a function can return more than one data type or yeah, tuples, yeah. And you're not tied to the number of returns that you can have in here. Like in this case, for example, hello world I will receive a string here, and I will return hello plus the string bonjour and the other. That's all. Again here, okay, here the assignment again here. We have the assignment. In this case, this is a string, but you don't need to to tell Golang that you're going to use a string. The for loop, again, for loop looks pretty much as you have the for loop in C or C++. The only key point in here is that you should not use parentheses on this, but that's all. Okay, that was in terms of the variables. Let's go to structures. Okay, let me show you. Everything in Golang start with this function main. So you only have just to write this and call any other function that you create from any other packages, but just inside the main function, like in the classic C or C++ language. So right now I'm going to show you what is the advantage of using interfaces. So here is one of the confusing parts of using interfaces and added methods to a structure. As I told you, you define a function using the word funct, and in here you pass the signature of your function. But in this case, if I want to touch the method amount to pay to the employee structure, the function should contain as the first thing will contain what structure I want to touch this function to. In this case, I will touch it to the employee structure. So we can read this like, okay, employee now has the amount to pay structure available, and that's all. And at the same time, when I'm yes.
So if you do that, do you have to do it in the same file, or can you do it in any file?
Any file. Any file.
So that means that you can actually extend types.
Yeah, correct. One of the great features about this is that you not only have a way just to reference built-in data type, but you can also say something like, for example, an employee has, for example, a computer. So you can say something like this. And computer in there is a structure that could be in this file or in another file. It all depends. One of the things that I like from Golang is that you can compose your data types, and you can think of better, I would say, because for example, coming from Java or Python, you have to think about, okay, this class inherits from this one, and sometimes it's difficult to think in that way. So Golang encourages you to compose your data types.
Okay, yeah, it's by composition.
Yeah, that's it. Yes.
Do you have an example of where you use that employee amount to pay?
Yeah. Let me show you, because that's a cool thing. Let's say that, for example, we want to calculate the amount to pay for any employee, but we have several different types of employees. For example, remotes have one payment model, but people in the office have other, or people from other country, we pay in a different currency. That it's a different example. So if you start coding amount to pay, or let's say that I want to print the invoice, for example, the details of the invoice, in this case, here, details. If I tie the function to a specific kind of employee, I will have to write the details function for employee type, office employee type, from other country. That's all. That you have to write everything. So you don't need to do that. You will hide everything on an interface, and the interface is constructor. So no matter if you pass employee type A or employee, I don't know, any kind of constructor, it will automatically call the function amount to pay. And it's like if you're if you're a contractor, I can call amount to pay, and amount to pay will take care of getting the details. But I don't have to know how you calculate the amount to pay. It all depends on the kind of.
Okay.
Question, Steven, sorry, I might have missed it. Where are you extending employees to?
Yeah, I think that's where.
Have you heard about book typing?
Yeah, really.
It's something like that. If he quacks and he walks like a dog, like a dog is a dog. It's something like this. In this case here, I defined a contractor interface, and a contractor should have this this method, amount to pay. That's all. It's just the signature. If I put that signature exactly the same in my interface, in my type employee, if you see amount to pay, hours, exactly the same signature and return type, it means for Golang would say, okay, this one is a contractor because he has exactly this signature and this return type. That's the way it will identify it as a contractor. So that's one of the cool things that, for example, if you want to override, let's say that I want to be able to print, because for example, Golang has this method to print things, to print strings, the print f or print ln. I can just put on my own module I can just implement the interface to print strings, and if I do it, I will override built-in method from Golang to print the string. That's it. Okay, one cool thing about this, but not related of what we're doing, is have you had problems trying to format your code and go in any programming language?
Go for it.
Go. That's it. You just go format and, for example, struct example, and it will automatically format your file for you. That's it.
People are not fighting about what's the format of the documentation because Go already has a standard.
Correct. Yes. And one thing, sometimes you start like writing some code, but let me do a quick example of it. Live example. So, for example, here, package main, and the function main here, blah. And let's do this. Okay, I will import a built-in that is format, the one that is in charge to print stuff. So I'll do something like this: print ln. Go run live example. That's it. There's one thing. Run is used when you want to run your code, compile it, run it. This will compile it, run it, and delete the binary. If you want to ship your binary, go build on the Go file. That's it. But I wanted to show you this. If you do something like, okay, here I'm just doing a print statement. That's good. But let's say this. I want to use this variable. And close the file and go run live example. Look this cool thing. You are using a variable that you're declaring a variable that you're not using. So Golang will raise an alerts when you have things that you're not using. This happens when you're using modules or variables of things that you're not using. So that's I find this very useful when you're writing code. Okay. Next thing I wanted to show you, and is, I think it's I will show you just real quick. In In Golang, we have pointers, and pointers is the headache when you're working in C or C++. But basically, we're going to have pointers to reference the position in memory of an structure. Let's say that we want to pass a structure and change its internal internal properties. So you have just to point to the direction. So that's the classic C or C++ pointers. That's it. And now let's move to something more interesting, and that is Go routines.
Good question.
Yes.
Regarding pointers,
Yep.
does Go has any safe check to prevent you to leave them with pointers or overwriting data during runtime?
Yeah. One of the cool things about Golang is that Golang has built in a garbage collector, so you don't have to worry about cleaning memory directions or assignments or quotes. It will take care of that for you. There's the good part that Golang has. Let me try to find an where it gets more interesting. I think pointer. Yeah. The only thing in here is that, for example, if I wanted to modify the internals of a structure, I only have just to place the star in front of it, and that's all. But this thing is not too complicated. It's just that you have to think about if you're calling a function inside your method. If you want to modify internal properties, you will use the pointer. If not, if you want to do calculations outside the internal properties, you don't have to worry about pointers. That's it. Okay, so I'll move on in Go routines. One of the things that it's a problem nowadays is concurrency and parallelism. People tend to think that when you have threads on your program, you're doing things at the same time, but that's not correct. You're sharing CPU time between your threads or of your programs. That's it. And if you think about it, how many cores of your CPU are you using where you're writing programs? Probably one. Probably, well, you're not using the full power of your CPU or all the cores because it will run just in one core. So Go has a nice feature where you can start creating your own concurrent function, but it will take care of placing the function in any of the cores. For example, if you want to use the full power of your CPU, you just only have to create a Go routine. So let's talk about Go routines. Go routine is a way that you can run functions in a concurrent way. So all you have to do is just to place the keyword Go in front of the function call statement. That's it. In this case, I have an example that is really good example for this. Is this one. I'm going to increase blah 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 here. Okay. Pretty much everything is the same as we saw, the function and all of that, but I'm going to show you a real example. Let's think about this. Let's say that we're writing a web crawler and we want to crawl several websites. I grabbed a list from the internet about people doing. I mean, here there's a list of URLs from LinkedIn with people that reach other people to make projects and all of that. So I have this list of URLs, this list and this other list. And basically what I want to be able to try to see if the URL is still valid. How I will do it? I will try to run a curl call, or I want to just to run a get, HTTP get, and see if I detect anything. It means that the page is at least is up. But the problem is that I want this to process both lists at the same time, or at least in a concurrent way. So I'm creating here Go routines, and that here is the example. It's pretty straightforward to read it. Basically, what I'm doing in here, I'm getting the web. This function will get any URL that I put in here. If you see the function, the name of the function, the parameters will be the URL, and I will return status and the web, the status and the web that I wanted to bring here. I'm using the HTTP module from Golang. I imported it just at the beginning of the file, in this case net-http, and that's all I need to do HTTP calls. In this case, http.get the URL, and it will return. If you see, I'm not sure if you're familiar with this kind of assignment, but we have a couple of variables, and we are assigning at the same time the value of the response and the value of the error, because http.get will return the response and the error status if there is any error at the same time. So if the error is nil is the data type to about null results. So if I have something, this error object will fill up and won't be the nil type, right? In this case, it will show me what is the error. If not, it will just return the status. That's all. That's what get page does. Okay. I have another method in here, and it's rich pages. Rich pages will take a list of pages, and if you see here, a page list is a data type that I defined, and the page list will only have the URL. That's all. So when you run rich page, I'm going to pass it a list of pages. That's it, and a name for a list. This keyword buffer, it's interesting, but you have to be careful when using it, because it will run anything that is below this call. For example, it will run the for loop, and at the end, it will run wg done. This wg, let me explain what it is. But basically, this for loop will take the array of page that I want to reach, and it will call the get web function. That's all it does. So when I'm finished with this, it will call, okay, done. What is this wg done? Basically, if you have Go routines will run, but it will run until your main function finished. So if I put go rich page and go rich page, the main function will run, and this go routine will run, but it will run up to the moment that the main function stops. As it doesn't have anything to do after this call, it will just end. So we have to find a way to synchronize the workers or the threads that we're creating here with the Go routines. And the way to do it is just to create a wait list, basically. This wg add would say, okay, I will have 2 threads at an array of threads that will be running. wait for having any function to call the done method. If you see here rich page, I'm executing it a couple of times, so it will call a couple of times wg done, and once I do this, it will finish the main function, and that's what it does. So let's see this in action. I'll run this like go run http go and pass the URL name, the URLs. If you see reaching website from list 1, from list 2, from list 1, from list 2, from list 1, there is no order because it will share the CPU time in between the Go routines. So this is just a simple example of using a couple of Go routines, but let's expand it to have, for example, 10 workers, 100 workers to do concurrent processing. This case is not only tied to get things on the internet, but for example, let's think about process files, process orders, process streams, anything, and you don't have to worry about how it will put or schedule the worker. All you have to do is just to put the Go statement in front of your function. It will take care of it. Around this, there are some models on how to place your workers, but that will worth another talk about that. But that's pretty much Go routines are being used too. And finally, I want to say that Golang is nice programming languages. A lot of people are using it, and people like, for example, Uber, Google, Indeed, Spotify, and other companies start working on Golang because of its model to do concurrency. Indeed, I think this last year Golang was introduced to AWS for Lambda, so it's really cool to start looking at this. And I think that's pretty much what I wanted to share with you. I really encourage you to take a look at that and try to apply this in any project that you have that has any need to use concurrency or parallelism. That's it. That's pretty much. So sorry. So I don't know if you have any questions, comments. Nothing. Okay. So I think that's
Wow.
all.